Hey guys, hope everybody's doing well and hanging in there. And we're just chugging along one day at a time here in our little math world, anyway. Today we're going to dive into the point slope form of the equation of a line. And there are going to be moments today where it feels like this is a little too elementary like, but I promise it's going to have value going forward and it's going to continue to kind of build us up as we continue to prepare to tackle some bigger bears down the road. So, what are we going to see today? So the first thing you're going to see is maybe they're going to give us 2 points and try to find the slope between these 2 points. And this idea of slope is going to be an ever-present theme as we go forward. And then we're going to get into writing the equation of a line. And specifically today, we're going to use something called the point slope form to write that equation. And sometimes we're going to be very fortunate and they're going to give us the slope and give us the point. And then there's going to be other times where we go to write that point slope form and we just get 2 points. And then so our first task then becomes, can you find the slope and then go ahead and write that equation. So anyway, let's see, what do we got for notes today? So real quick, this idea of slope is so much fun. Slope is a tool that we use to measure what? Yeah, we're going to use it to measure the steepness of a line. That's a really cool word right there. So slope in its essence compares the vertical change that we usually call the rise to the line's horizontal change that we call the run. Basically, as you're moving from one fixed point to another along that line. Now, to calculate that slope, we're going to use the ratio that compares the change in y to the corresponding change in x. So let's say I start here, even though it's called x sub 2, y sub 2, we'll call that our starting point. How far is our run compared to our corresponding rise? So in this case, you've got a rise of 1 block and a run of 3, so the slope would be a positive 1/3. So in general, when we say change in y, we're thinking delta y compared to the change in x, so that would be my delta x. And just like this formula says, that's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's right in our wheelhouse. Let's see if we can apply that to this problem right here. Now, again, it really doesn't matter, believe it or not, who you assign to be x sub 1 and y sub 1 versus x sub 2 and y sub 2. Traditionally, I'm just going to go from left to right. So the negative 3 is going to be my x sub 1, the 4 is my y sub 1, 2 is my x sub 2, and the negative 2 is going to be my y sub 2. So I'm thinking negative 2 minus 4 all over 2 minus negative 3, which makes negative 6 over 5, and that's all I've got to do. Now, in this case, you'll notice that slope is negative, so when you go to graph that line, it would be trending downward. It would be falling as we move from left to right. All right. So as far as the different possible lines that we've got, we're thinking, okay, we could be positive like this bear. We could be negative like this bear. Those are the two most common ones. But then we have these other two special variations. Now, horizontal means you have a slope of 0. And those lines, they look like y equals, a number. Like in this case, it might be 4. Now, going back to this one that I skipped, this vertical one, it has a slope that's considered undefined. And those lines are written as x equals a number, which in this case, might be a 3 or a 4. All right. Now, as far as the point slope form, now probably what you're thinking right now is you're thinking of the slope intercept form of a line, and that's a really good form, but it's depending on the situation and the context, it's not going to be as useful as this form that we're going to talk about today, and that's the point slope form. So we're going to get a little theoretical. We're going to get a little deep here for a few seconds. And so I want to jump in right here. I want you to consider a non-vertical line with a slope of m. All right, so let's try this bear right here. We'll just draw a real generic line. And it contains the point x sub 1, y sub 1. So let's say that bear right there is x sub 1 comma y sub 1. All right. Now, I want you to imagine a second point that we'll call xy. Notice it doesn't have any subscripts, and it represents any other point on that line that you can think of. All right, I'm going to be really boring, and I'm going to put it right here. So that'll be my x comma y with no subscripts. Now, keep in mind that pink one that I just put on there is an arbitrary point. What does that mean? It's not in a fixed position, okay? It's not in a fixed position. By contrast, the x sub 1, y sub 1 that did have subscripts is fixed, all right? He's kind of locked into place. Now, regardless of where you put this point, x, y, no matter where it's located, you could have put it anywhere on that line, the steepness remains the same, and therefore, what that means is the ratio of the rise to its run is always going to simplify to the same fraction, okay? So what does that mean? This means for all points along the line, my slope is guaranteed to be, let's say, y minus y1 all over x minus x1. And if I go ahead and if you want to imagine or pretend that m is over 1, we're going to cross multiply. We'll get y minus y1 equals m times the quantity x minus x1. And what we've done, we've just created the formula that we're going to use today. It's called the point slope form of the equation of a line. So I promise that's like the most deep theoretical thought that we're going to get into today. Again, just a real quick recap to give you kind of a hot air balloon view of what we're thinking here, math. So point slope form is the one we're going to use today. Slope intercept is probably the one you're most familiar with going back to Algebra 1. And there are definitely going to be moments where we do prefer that, just not today. We also have this thing called the general form. Again, it doesn't have its value today, but there will be other moments down the road where that is beneficial. And then, of course, you've got your two special cases, your horizontal line and your vertical line. And if you're familiar with and comfortable with all 5 of these, you're going to have a really strong foundation going forward. And that's all we want to do is our goal is to equip you with as many tools as possible so that you can be flexible and versatile as you navigate your way from problem to problem to problem. All right, so we're going to dive in and get into the meat and potatoes here. We're going to write the point slope form of an equation with a slope of 3, and it passes through the point -5, 2. For the sake of being extra careful, I'm going to rewrite my formula. And then I'm going to substitute the 2 for y sub 1. I'm going to substitute the 3 for m, and then the -5 for x sub 1. Now you'll notice I can go a tick further, and what I'll do is I'll write x plus 5 because of the 2 back-to-back negatives. In our next example, we've got a line that's passing through 2 given points, and so my first task is to find the slope. So let's say we want to divide our workload in half. The very first thing I want to just find the slope. And feel free to do these calculations, as much of these calculations in your head as you'd prefer. I think I'm getting 9 over -6, which reduces to -3 halves for my slope. Let me just double check and make sure I did that right. I think I'm okay with that. And now now that we have slope, we are going to write our point slope form of the equation. And what's fun about this is you have the freedom to pick either this point or this point. It does not matter. You're going to get a correct answer no matter what. Even if our answers may look different on the surface, they are going to be equivalent, which is always a good thing. I'm going to go with this bear here. So I'm going to say y plus 3. Now, why did I say plus? Well, it was technically y minus -3. And then I've got a slope of -3 halves and x minus 4. And maybe there are going to be times where they want you to solve this for y, but I'm not going to worry about it today. Certainly, I think we're capable of doing that. We could distribute the -3 halves if we had to. And then here, I just want to wrap up with a real quick activity where we get really, really good and comfortable at finding the slope of a line. The nice thing about this is we've kind of replaced numbers with letters, which really helps us focus on the process and not so much the final answer, which is something I always like. So in this first example, if we go through here and I consider this x1, y1, x2, y2, my slope is going to be 0 minus a all over b minus 0, which makes -a divided by b for my slope. Let's see here. Let's call this x1, y1, x2, y2 if you want. So we could say -b minus 0 all over 0 minus -a. Watch that bar right there. So we're going to get -b over positive a. And so make sure we've got minus and a negative right there. Let's see. Okay, what's C looking like? Oh boy, let's try red. See if that. We've got x1, y1. Let's call this x2, and then b plus c is going to be my y2. So I'll start off with b plus c, and then subtract b, and then I've got a minus a. Ruh-roh. So I'm getting c divided by 0. Anything divided by 0 is undefined. So we would say this slope does not exist. In other words, the line that connects these 2 points is going to be a vertical line. All right, we got one more bear here to jump on. Oh, shucks. Let's see if this one shows up. All right, so a minus b is my first x, c is my first y, a is my second x, and a plus c is my second y. So let's go a plus c minus c, and then we could do a minus. Now watch this, the quantity a minus b. Those parentheses are actually a really big deal because I've got to distribute a negative sign. Not sure I'm really in love with this color right here. So let me see if I can switch colors. Might as well. Why don't I just stick with black, huh? All right. So on the top, the C's are going to cancel. On the bottom, I'm going to distribute the negative. The A's are going to cancel, and I end up with a positive B when I'm all done. So there's my final slope. So hope you enjoyed our talk about slope and the slope-intercept form of a line. If you got any questions, throw them in the comments below, and we'll answer them as quickly as we can. Good luck, guys.